Hello, I'm going to do a lesson on how to do sine of 20 degrees by making a drawing of a triangle. And so normally you would write sine of 20 degrees, you abbreviate it SIN, and then parentheses 20, and then the little degree sign. So we know it's not radians, we know it's degrees. Now, of course, there's calculators and so forth, but to build up the intuition of what this trigonometry is all about, it really helps to actually draw a triangle out and measure to see what this is. So we know that by definition, if you have just some generic triangle, you have some generic angle theta right there, we know we have the opposite side, we have the adjacent side, we have the hypotenuse. And so we know by definition that sine of theta is opposite over hypotenuse. I'll just do OPP over HYP to abbreviate there. So let's draw a triangle. So this is a Onenote in Windows, and that I'm using here. So they have a little ruler thing, and it's really clever. They have a little measuring device for measuring angles as well. So let's just draw ourselves a triangle. Of course, if you have just ordinary paper and pencil, that works just as well. But for this video, I'd like to use this this little device here. There's an online website, which I'll show you a little bit later. Also, they can do this sort of thing. So let's just measure a 20-degree angle. It says 20 degrees right there, and draw a line there. And when you're drawing your lines, it doesn't really matter if the lines overlap or not. In fact, it's a little better if they overlap a little tiny bit. Let me erase this. I'll need the space here, and then I'll turn my ruler, make sure it's 90 degrees. Okay, and then just oops, I erased it. I didn't mean to erase it. I'll have to draw it again. Okay, so there's my 90 degree. All right, and then back to draw the horizontal line. Now remember, it doesn't matter how big or how small that rectangle is, because it's the ratios that matter, and that's always the same. So for any 20-degree angle, so right here this is 20 degrees because I measured it to be 20 degrees. For any right triangle, and this is 90 degrees, put a little 90-degree symbol there. So for any right triangle, as long as you have 20 degrees here, then the ratio of the opposite side, which is this side over here, divided by the hypotenuse will always give you the same number. And so now let's go ahead and measure these. So the hypotenuse, now this ruler doesn't have any numbers on it. So we just have to, we'll just pretend this is centimeters. Just take one of those major lines and line it up right at the corner. Now it's not going to be exact, but that's okay. Make sure it's at 20 degrees. Oops. Okay, good enough. Okay, so I'll start here at 0. I'll just pretend this is 0 right there. And I'll count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. It looks like about 14.4. Okay, all right, 14.4. Okay, there's my hypotenuse. Now I need the opposite side, so let's just move the ruler over to here. Line up the major mark right there at the bottom. Okay, and let's measure this. So this is 0, 1, 2, 3, 4, 4.9, maybe 5.0. Let's say 4.9. Okay, so so we know now sine of 20 degrees equals to, by definition, opposite over hypotenuse, which in this case is 4.9 divided by 14.4. Okay, and just get out a calculator and let's divide this here. So 4.9 divided by 14.4 is about 0.3402. I'll round it to 0.34. All right, so how good of an approximation is that? So, of course, on calculators now, you can do sine of 20 degrees on a calculator. Any calculator works fine. This is just the standard calculator that comes with Windows. I showed you this earlier, but you can see trigonometry. There's a button for sine right there. Some calculators by default are in radian mode, so you just have to make sure you're in degree mode, first of all. So on this one, you just type 20 and then press sine. And there you go, 0.342. So if you round off to 0.34, it's exactly the same. So that shows you that really, indeed, the sine of 20 degrees really is the ratio of the opposite side divided by the hypotenuse. So on the calculator, it was 0.34 as well. All right. Now, of course, like I said, just ordinary paper and pencil. If you have a protractor and a ruler lying around, that's a really nice way to do this. This is Onenote. However, as a backup, if you don't have a protractor lying around, there is another website. I drew this already just to save a little bit of time. Here, let me type the name of this website because it's cut off. Here, it's called mathspad.co.uk/i2/constructs.php. I'll put that in the description for this video as well. But this website is just a website where you can draw stuff. I'm sure there's other websites out there where you can draw stuff as well, but this one has a protractor right there, so you can measure. Here's 20 degrees, and the protractor, it snaps to the corner, which is really nice. And just use your just use the little pencil, and you can mark off 20 degrees, and then you can draw your line. Draw lines, that's the thing for drawing lines right there. And then there's a ruler right there. And then you can use the ruler to measure the length of the sides. You can turn the ruler. There's a little, if you move the cursor to the end of the ruler, the symbol turns into a little rotation symbol, and then you can move the ruler around like that. You can drag the ruler so you can measure the sides of the triangles. So it's just another way to get your triangle drawn now and measure your angles as well. Now on this triangle, this was a little bit sloppier, but I got 6.5 for my opposite and 20.1 for my hypotenuse. So just for fun, let's go ahead and divide these two, and let's see what does this triangle say sine of 20 degrees should be. So theoretically, it should be the same because the size of the triangle doesn't matter. What matters is the ratio of the sides, and the ratios are always the same if you have a 20-degree angle there. So 6.5 divided by 20.1. Okay, we had 0.32 before. Okay, it was 0.34. Now this is 0.32 right there. So it's off by 0.02, but still very, very close. But like I said, the measuring was a little bit sloppier when I did this one. But the main thing to remember is any triangle that if it has 90 degrees on one corner, and then the other corner has 20 degrees, then no matter how large or small the triangle is, the ratios of the sides will always be equal. And that's why sine of 20 is always that same consistent 0.34, at least theoretically, if you measure everything perfectly. All right, that's it for this